Hi everyone. Today I, Dhruv Gupta, and my teammate Siddharth Sharma are going to talk about our project, Resume Passing Service. Resume screeners are software where machine learning algorithms are utilized to automate and enhance the candidate selection process. This helps organizations in selecting suitable candidates for their job postings. Traditional resume screening processes are often time consuming and are prone to human bias. Manually extracting relevant information from resumes like the skills, education, and contact details adds another layer of complexity to this process. Hence, this is an end-to-end process that leverages machine learning techniques to categorize resumes, provide job recommendations, and extract vital information from the resumes. As part of this presentation, we will discuss all these contents. Project goals. The main goal of this project is to create a resume passing service that acts as an end-to-end solution for the hiring process. The candidate will upload the resume using the front-end web page. Resume will be saved as information at the back end and at the same time categorized into a particular field of job category. This parser also provides a recommendation for a job profile that the resume can be applied for. Software and components. For front end, we use HTML-based APIs to create the web page. This web page is connected to a backend which is created using Google Cloud Storage components like buckets and databases. We are utilizing Python programming language along with libraries like sklearn and feature extraction for creating the recommendation and categorization models. The script is being run on GCP virtual machine to ensure good processing and operating capability. Users interact with an API frontend to upload the resumes, which are sent to the backend via API requests for processing. The backend is hosted on a virtual machine and it utilizes NLP libraries to parse the resumes, extracting and organizing the data for efficient retrieval. The structured data is then stored in Google Query storage for easy access by recruiters, while the raw resume files are saved in Google Cloud Storage for reference. The front end integrates with the database to present the structured data, enabling recruiters to view and manage candidate information seamlessly. We added logging statements to monitor the flow of downloading models, file uploads, and predictions. We debugged Google Cloud Storage access and verified bucket existence and model availability. For unit testing, we tested functions like PDF to text, clean resume, predict category, and job recommendation individually with various inputs. We validated extraction functions for contact details, skills, and education with resumes containing diverse formats. For integration testing, we did an end-to-end testing of the Flask application, including file uploads, model predictions, and results rendering on the UI. We verified the GCS model, download integration, and interaction with the backend. We performed load testing and UI testing along with data validation, where we used resume with known details to confirm prediction, accuracy skills, extraction, and email phone recognition. Now Siddhant will continue with the demo.
Here is a demo for resume parsing services. In the first step, we will set up the project in the Google Cloud. With the help of Google Config ID, we will be establishing a working environment for our project. In the next step, we will be creating a bucket for storing the dataset, which is the foundation of training our machine learning models. Think of this bucket as a secure cloud-based folder where we also save training models for dataset. The next step, we will execute Python script called resume categorization prediction. This script uses random forest algorithm, which is a machine learning model well suited for classification problem. It will process the dataset, train the model, and save their following files in the bucket. After training the first model, we will move to the next step by building the job recommendation model. This involves executing another Python script that also uses the random forest to predict the most suitable job for the client based on their resume. We have created a template folder to store the resume.html file, which will be our front end, and app.py, which will be our backend services. In the next step, we will create virtual machine. This virtual machine is where the VM makes sure the backend services and machine learning models are running successfully. In this Python script, we will set up the virtual machine and install all the required libraries in virtual environment. Transfer the trained model files and the backend services file app.py to the VM by running another script called download_gscpy. In the last, this script creates a firewall rule for the port 5000 to allow traffic on this port. We need to ensure everything has been set up correctly. Now, after executing the command ls-a, we will see that app.py, our backend server file, is present. Our models folder, which is having the trained model, and the templates folder containing the front-end resume.html file is present. Now we will execute our virtual environment my_env. We will run our backend services. Now we can clearly see our backend services are working. Now we are accessing the resume.html file with the help of VM external link. Once submitted, the system processes the resume and provides the resume category, job recommendation, and other extracted details from the resume. Thank you.